Hello everyone, this is video 6 in the college algebra series, and in this video I'll be talking about average rate of change. So the average rate of change with respect to x is as x changes from x1 to x2, the ratio of the change in output to the change in input. So we have the ratio of the change in output to the change in input. This essentially means we are trying to understand how much our y value is changing as our x value changes. So in algebra, this is known as the slope. For a curve, we can find the slope of any secant line between 2 points. So for example, if we had a graph that looks like this, and we have 0 and 2, and this is 2. So if we want to know how much is y changing as we move from 0 to 2, is basically trying to understand what is the difference between y2 and y1. So the change in y, so change in y would be y2 minus y1. And the change in x here would be x2 minus x1. So that is how much our y is changing, and that's how much our x is changing. So if we want to know what our average rate of change, that means what is the average of how much y is changing at each and every point from when we start from 0 and end at 2, would be y2 minus y1 divided by x2 minus x1. So that is what we have here as our formula. We have our average rate of change. So average rate of change is y2 minus y1 divided by x2 minus x1. If you look at this, it looks exactly the same as our slope formula from the previous videos where we discussed the point-intercept form, the slope-intercept form, where we have y equals mx plus b as our linear equation, and m here essentially is y2 minus y1 over x2 minus x1. This is rise over run. Okay, so let us do a couple of examples to familiarize ourselves more with the average rate of change. So in the first question here, we are given a function which is defined in this way, and we want to determine the average rate of change where x1 is going from -3 to 0. So let me write down the formula again so we know what we have, and we also know what we need to be able to plug in stuff into the formula. So average rate of change is equal to y2 minus y1 over x2 minus x1. y2 is f of x2 and y1 is f of x1. And then we're dividing it by x2 minus x1. So we have the numerical values for both x1 and x2, and we can plug in both of those into our f here and find our y2 and y1. So let us do that again. So we have y2, as I mentioned before, is f of x2. That means it's f of 0. That is 0 cubed plus 2, which is 0 plus 2, which is 2. Similarly, let us find y1, where it is f of x1, which is f of -3. So this is -3 cubed plus 2. So 3 3 is 9, 9 3 is 27. So we get -27 plus 2, which is -25, right? And now we need to plug in. So now we have our y2, we have our y1. So we have y2 and y1, and we're already given what our x2 and x1 are. So all we have to do is plug it back in into our formula here. So y2 we have is 2, y1 is -25, x2 is 0 and x1 is -3. That would be 2 plus 25 divided by 3, which is 27 by 3, which is 9. So our slope here is 9. That means our average rate of change is also 9. All right. One thing to be careful, because here we do not have a linear equation, the slope is not constant at all times, right? So if we had a linear equation, if we just had a line, something like this, or anyway, the slope is always constant. But here you see this is a cubic equation, and here one thing to make sure we understand is the average rate of change is dependent on which x values you're actually looking at. So this is the average rate of change only between x1 being -3 and x2 being 0. All right. Let's move on to our next question here. So it says, the graph of a function f is shown below. Use the graph to find its average rate of change from x equals 3 to x equals 7. So let me write down the formula again. We need average rate of change, which is change in y divided by change in x. So this is change in y and change in x. We have x2 and x1 already given to us. Let us take this is x1 and this is x2. So we are given x1 is 3, x2 is 7. We want to find what is y2 and y1. So when our x1 is 3 here, so that is, this is x1 is 3. Let us draw a vertical line to see where it intersects our graph. And you see it intersects at -6. So the y value that is corresponding to x1, that is f of x1, is f of 3, which is -6. Now let us find what is the y value that's corresponding to x2, which is 7. So this is 7 here. Let's draw a vertical line again. And it's exactly the same place. So our f of x2, which is y2, is f of 7, which is also -6. So now we plug it in into the formula. We get -6 plus of -6 divided by, it's y2 minus y1, so it's -6, negative of -6 divided by change in x, which will give us 0 divided by 4, which is 0. So that is our average rate of change, which essentially means, as for example, you can think this as time and this as maybe your path that you're taking, or y could be your path. So you're essentially saying, if you just assume all of this is positive numbers for a second here, it's saying that you're taking a lot of time. You're taking maybe 4 minutes, and you're coming back to exactly the same place you were 4 minutes ago. So that means that your average change is 0 because you're still at the same point that you started at. That is why here we see that the average rate of change is 0 because it's at the same point. Like as x changed, though y changed in between at that point, so the average change here is 0. All right. Okay, this is the last question here we have. So Abdul is cooking a roast. The table below gives the temperature R of T, and the time is given in minutes after he removed it from the oven. All right. So we want to find the average rate of change for the temperature from 0 to 30 minutes. So we want to know how is the temperature changing on an average from 0 to 30 minutes. So let me write down the formula again. We have y2 minus y1 over x2 minus x1. Here y2 and y1 would be r of t2 minus r of t1, and x2 would be t2 minus t1 would be x1 would x1 here, oops, I put an x2, is t1. All right, so what is r of t2? Let us assume this is time 1 and this is time 2. So the corresponding temperature is 193.5 minus T2 is 130.5 divided by T2. I did T1 minus T2. Let me erase this and write it consistent with our formula. So that would be 130.5 subtracted divided by x2 minus x1, which is T2 minus T1, that's 30 minus 10. So this would be 63 divided by 20. So that is the average rate of change for the temperature from 0 minutes to 30 minutes. This would essentially be 63 by 2 times 10. So that is 236 and 1.5 by 10, so 3.5. So essentially our turkey is cooling down, negative everywhere, is cooling down 3.5 degrees every minute. That is what it means. It means that our rate of change is 3.5 because we're talking about average rate of change. We're averaging over the 30 minutes. So we are saying that per minute, the roast here is cooling down by 3.2 degrees centigrade. Okay, so here we have another part for this question. We have to find the average rate of change for the temperature from 60 minutes to 75 minutes. So 60 minutes is our x1, 75 is x2. Let us get the corresponding y1 and y2. So y1 is 73.5 and y2 is 22.5. Plugging it back into our formula, which is y2 minus y1 over x2 minus x1, we get y2, which is 22.5 minus 73.5 divided by 75 minus 60. That would be 50, 72, 73. So that's 51 divided by 15 here. Let me plug it into my calculator and get the exact answer. So here it is 51 divided by 15, which is 3.4 again. So it's negative 3.4. So between 60 minutes and 75 minutes, per minute, the roast is cooling down at the rate 3.4 degrees centigrade per minute. So why are we seeing that there is a negative number? Because it kind of represents that it is cooling down. That means if you think about it, as you say the temperature is increasing, you would go to the positive side, and as you say the temperature is reducing, that means your slope is negative, right? So if I plot this and say that maybe I take out the roast from the oven at this point, so the thing in the oven would be heating up until this point, and then it would at some rate go down. So in between the time that you get it out of the oven, so this is going down, right? The temperature is going down once you bring the stuff out of the oven. So your slope is negative at this point, because if you see, it's pointing downwards. That is why we have the negative here. It essentially just means that it's cooling down. It's the same thing if you think about it as your speed when you're driving. So your slope is going to be negative when you're slowing down, when you're trying to press the brake, but as you're accelerating, your slope is positive for your function. That means you're speeding up. So that is the end of average rate of change, and I will see you in the next one.